Hey everyone, what is going on? Welcome back to another video here on the channel. In today's video, we're going to be talking about when should you dispose of your lithium polymer battery pack. Essentially, when is your pack considered as no longer good for a radio control vehicle? The way we're going to do this is we're going to break it down into three sections, where the first section, we're going to look at the safety aspect of a battery pack and take it on from that point of view, because safety is priority number one when we're just trying to have fun. Then section two, we're going to look at performance metrics. These are performance metrics that we're able to measure within our pack, and you can actually measure these parameters with your own charger, the ones that we're going to go through. And then the third section that we're going to have here is essentially a summarization, a quick summarization on when you do get to this stage, because if you're in the hobby, you are going to be getting rid of lithium polymer battery packs. That is a certainty if you stay in the hobby for long enough. And you should expect to go through a process to get rid of them that is going to be safe within your local area. And we're going to go through exactly how we discard a lithium polymer battery pack. Now let's start off and talk about the safety aspect of a lithium polymer battery pack. Obviously, this is very critical and important for all of us. The most obvious reason why a lithium polymer battery pack could be at its end of life is because it gets physically damaged. Now, it can get physically damaged in a couple different ways. It could be something that you do within the battery pack. If you do crash it with a radio control car, plane, boat, whatever the case may be, you could have physical damage on that pack. And wherever there's physical damage, that means that that section of the battery pack is going to be more sensitive to fracture, more sensitive to tearing or splitting open. If you have a soft case lithium polymer battery pack, it's quite easy to actually puncture the cell packages that the cells are contained within. And if you do that, you are essentially letting some gases out, and as soon as that interacts with the environment, flames do happen. So it's very important not to get to that stage, or if you do, to dispose of the pack, discharge it, get rid of it, because it is no longer safe to keep it. The second way that we can actually get physical damage from a lithium polymer battery pack is if we end up overheating the pack too much, or we discharge it too far, or we overcharge it. We could experience some form of ballooning. Ballooning happens when there's gases that are built up within a cell, and it actually causes the cell to expand. And this is obviously dangerous because there's some pressure built up into the cell, and if it does puncture because of too much pressure, this is where you can get a flame coming out that puncture wound. If this is something that happens to your battery pack, I would highly suggest getting rid of it, as it's simply not worth the cost. Now let's move into section number two and discuss some performance metrics around our lithium polymer battery pack. The second section is dealing with the internal resistance component of your lithium polymer battery pack. Now, as it relates to resistance, this is something that you can easily get from your charger. If you have a modern computerized type charger, you can get this performance metric. And I would highly suggest doing this as soon as you get the battery on your very first charge. Pay attention to these numbers that you do get. Let's say if you follow the typical scope of measuring this parameter here on the channel, which means you're charging at a rate of 1.5 C and you're taking the measurement as it comes up on your charger within the first minute or so, this has to be consistent for each one of the measurements that you're going to do from now on. And if you do it this way, then you're going to get some accurate, or at least more accurate, results. Once you have the initial value from brand new, any time well into the future is going to give you a worse result. This is because, as we went through in a previous video, only a couple of videos ago, where we talk about the chemistry in a lithium polymer battery pack, the chemistry and what happens inside the cells actually degrades over time for a couple different reasons that we discussed in that video. And as such, your batteries are never going to get better. They're always going to get worse off as time goes on. So this is something that we can monitor by just measuring the internal resistance of a lithium polymer battery pack. The general rule of thumb that I provide is if your battery cell exceeds the value that you first had when you first charge it by a ratio of 3, this is a sign that tells you the performance of the battery pack has degraded significantly, and some radio control vehicles will not even be able to operate properly if your internal resistance of a cell goes up by 2 to 3 times the original amount. What happens is you draw so much power from the pack and the pack simply can't provide it, and you may hit low voltage cutoff. My recommendation, 2 to 3 times. If you're exceeding the 3 times, then the battery has degraded far enough to render it as something that should be discarded. And the second performance metric that we can go based off of is capacity. Capacity is a good one because originally when you end up charging your battery pack for the very first couple times, you're going to be able to see how much capacity you put into that pack. I'd recommend if you're going to do this to charge it at a rate of 1C, making sure that you're at the 0% capacity of the battery pack and charging all the way to 100%. If you're, for example, using a 5,000 milliamp hour pack, and let's say you actually get exactly 5,000, it's very rare that you're actually going to get 5,000. If you do get 5,000, my recommendation would be anywhere from 70 to 80% capacity. So 80% capacity on a 5,000 milliamp measurement would be 4,000 milliamp hour. And if you're working with the 70% value, that would simply be 3,500 milliamp hour. Both of those values will be sufficient, and you can ultimately decide which one you want to follow. What is really interesting is this rule is not just all about radio control. This rule is also in the EV world. If you see a battery pack out there in an EV and it degrades to the point where it's less than 80%, or even less than 70%, that being obviously much more degraded, this is when the electric vehicle companies do consider a battery as essentially end of life. And we should adopt the exact same rule for our electric radio control vehicles and consider our battery packs as dead when they reach that point. Now, if you're comfortable pushing it beyond these 2 performance metrics that we ended up talking about, that's completely up to you. My recommendation would be when you hit these marks within your lithium polymer battery pack, your battery pack is telling you, based off of the chemistry issues that we talked about earlier, it is degrading and it has reached end of life. I also want to include just a little bit more information as it relates to metrics. This is not a performance metric that we're going to measure up against. So don't base your decisions off of years alone. We're going to talk about the years of life that we should expect out of a lithium polymer battery pack. In general, you should expect about 2 to 5 years of life for a lithium polymer battery pack. If you're getting upwards of the 5-year mark, you're doing pretty good. And if you're reaching those performance metrics after 2 years, unfortunately, yes, lithium polymer battery packs can actually be at the end of life at the 2-year mark. It may just mean that you're using your battery pack more times per day than somebody else. We have the same metric in terms of cycles. You should expect to see anywhere from 200 to 400, maybe even 500 cycles out of a really good quality lithium polymer battery pack. If you're upwards of 400, 500, you have nothing to complain about because that battery has served you well. You may find that 200 cycles is all that you can get out of a good quality battery pack as well, based on how you use it. So there are many influences that come into play when we're talking about the lifespan of a battery pack here as well. Last section to cover here is eventually you are going to reach that point where you have to get rid of the lithium polymer battery pack, and it's good practice to do it in a safe way. Now, my recommendation going through this very quickly is that you take that battery pack and discharge it down to 3.0 volts. I would do this at about a half C rate just to make sure that you don't build up too much heat within the cells of the battery pack. Discharging at a slower rate prevents the buildup of excessive heat over time. Once you've successfully gotten the pack down to that voltage, you could do one of a couple different things. You can either place your battery pack in a salt bath, that is essentially salt and water mixed there in a container, throw the battery pack in there, make sure that that system is in a good, well-ventilated area so that the gases that could come out can escape into the environment and not feel anything that could end up causing an explosion if a flame were to light these gases. So that's why it's important to be in a ventilated area. The other option that you have, and this is one that I have used frequently, is to just place a high ohm resistor onto the battery pack leads. We're talking anything in excess of like 150 ohms or so. This is going to give you a really slow discharge rate to make sure that your battery cells won't overheat as they're discharging the power from them. Ultimately, what you're trying to do with both of these is get the voltage down to 0, and then once you're at 0 volts, all you need to do is do what I've done here. I got so many of these packs right in front of me where I've taken them and essentially applied solder to the leads and solder both the leads, the plus and minus of the battery pack, to each other, which does short the pack out. So I know that all of these are at 0 volts because we have dead shorted all the leads. So I've done this on my 4S packs that are essentially ready for disposal. Here's a 6S pack, and you can see that that has now one of the leads that is soldered to the other one. So now all I need to do with all these battery packs, I think I have about 6 or 7 of these to bring to my local disposal facility. That's where those guys can take these packs off my hand and dispose of them the best way that they know how to do. Well guys, that essentially does it for this video. I hope you learned something about lithium polymer battery packs and the performance metrics that surround the lifespan of the pack, as well as the performance of the pack, ultimately allowing you to know when it's time to simply get rid of them. As always, like the video if you do. Don't forget to hit that sub button, and I'll see you in the next one. Thanks a lot for watching. See you in the next one.